All right, section 3.3, modeling with functions. This is a very important section because we're going to learn about independent and dependent variables, and we're also going to learn about function notation. Function notation tends to confuse a lot of students, but I believe that if you watch this video, you'll figure it out. You'll know what it is. You'll know how to read it. It's really about how to read math. It's not really about solving a math problem. It's about how to read math. So it's more like an English class today, in a sense. Not really, but in a weird way, you can kind of think of it like it is. Okay. So let's start by independent and dependent variables. The input of a function is the independent variable. The output of the function is a dependent variable. Now, something to point out, and we wrote this in the margin in class, is that we've heard a lot of stuff that refer to the same thing. So x values in general, I'm going to switch back to red. I was using black earlier in a different video. Going back to red. X values in general, when we talk about domain, we talk about x values. When we talk about input values, we talk about x values. And now we're talking about independent variables. Guess what? Independent variables is also talking about the x values. So anytime you see any of these words, domain, input value, independent value, we are always talking about the x values, okay? And for the y values, we know that y goes to the range. Y is the output values. So when you see the output of a function, again, it's referring to the y values of the function. And now we're also calling it the dependent variable, the dependent value. Okay, so keep that in mind as we go. In the winter, more electricity is used when the outside temperature goes down and less is used when the outside temperature rises. So to determine which variable is independent, which one's dependent, we have to figure out which one affects the other, or which one is dependent upon the other. So the independent variable will affect the dependent variable. Therefore, the dependent variable depends on the independent variable. It depends upon something else occurring. So in this case, we have two things to consider: electricity used and temperature. So which one relies on the other? Electricity depends on the temperature outside, or I should say the electricity used depends on the temperature outside, or does the temperature outside depend on the electricity I use? The answer should be obvious. The electricity that I use depends on the temperature that's outside, because how could the temperature outside depend on the electricity I use? That means basically, if that's saying that the temperature would change based on the electricity that I use, and I can't change the temperature outside just based on the electricity I use. That doesn't make sense. So what does make sense is that the electricity I use is depending upon the temperature it is outside. So the dependent variable is electricity. I keep writing an I there. I don't know. I keep thinking about the I part of the word. Because electricity depends on the temperature, not the other way around. Independent is the temperature. Remember how I said the independent variable would affect the dependent variable. So temperature will affect the electricity that I use, whereas electricity is affected by the temperature. So you can think of it that way. Dependent variable is one that is affected, and the independent variable is the one that's affecting that other value, that other variable. The cost of shipping a package is based on its weight. So in this case, the independent variable, or let's say the dependent variable is the cost of shipping. The cost is going to depend on the weight of the package. The cost depends on the weight of the package. So our dependent variable is cost, and our independent variable is weight. Because what's going to happen is the weight of the package affects the cost the package is. Affects how much it costs to ship it. The cost to ship it does not affect the weight of the package. The weight of the package affects the cost to ship it. So remember, the independent variable affects the dependent. The dependent variable is affected by the independent variable. The faster Tom walks, the quicker he gets home. Now, this one's a little bit different because it's actually using words that's not in the problem. But in this case, the time it takes to walk home depends on the speed he walks. So the time it takes for Tom to walk home depends on the speed that he walks. Because if he walks slower, it will take him longer to get home. If he walks faster, it takes him a shorter time to get home. So the time is affected. The time he's walking is affected by the speed at which he walks. So time is dependent upon the speed. The speed will affect the time it takes for him to get home. The time it takes for him to get home does not affect the speed that he goes. The speed that he is going will affect the time that he gets home. So given a situation where time is the dependent variable and distance is the independent variable, in class we came up with a lot of these. The one I liked, I think, the most was going from class to class. So for example, the farther away your class is, the longer it will take to go. So this is relating time and distance because the time it takes you to get to class is dependent upon how far away that class is. So the time it takes to get to class is dependent upon how far away that class is. So the farther away your class is, the more time it's going to take. Whereas if your class is right across the hall, it won't take that long at all. Okay. So moving along. Now, this part, function notation. This is a very, very important part. This is the part that I think people read math and they get confused by. So if you know how to read math, it's very simple. But if you don't know how to read math, it's very confusing because you look at certain things and you go, what does that even mean? But if you know, that's what we're trying to figure out in this video. So function notation. X is an independent variable. Y is a dependent variable. We talked about that earlier. Function notation is written this way. Y is equal to f of x. So what this means, it says y is equal to f of x, or y equals f of x. F parentheses x is pronounced f of x. So let me clear up a little bit of confusion real quick. When you see f parentheses x, right, this is called f of x. It does not mean f times x. There's no multiplication going on here, okay? It's not mathematically representing anything. It's really what it is. It's just a name of a function. It doesn't actually indicate any multiplication. It doesn't indicate any kind of math like that at all. It is just a name for the function. So let me illustrate my point a little bit here. So let's say I have a function. Let's write it as y equals 3x plus 4. Now, that's written in the standard notation. However, function notation would be written the same equation as f of x equals 3x plus 4. There is no difference between these two equations. They both mathematically mean the same thing. F of x is the same thing as y equals. So there's really no discrepancy there. F of x equals is the same thing as y equals. But this one's written in function notation. And the reason we use f of x is because it gives us a little bit of versatility. And I'll show you what that versatility is as we go in the next several minutes. I'll explain it all. But we use f in general. We can use kind of really technically any letter, but you're going to more often see f of x rather than anything else because f kind of stands for function of x, right? When we say f of x, we kind of really mean a function of x. So what we're saying is that this function is called f, and it's using x as its variable. And you can see that x is the variable that's used in that function. You could call it f of t. f of t would be the function, but with t as the variable instead of x. So you wouldn't say f of t and then have 3x plus 4, because you're saying that you're going to have a function of the variable t, and there is no variable t. So you have to have t in that function to represent it properly. It's saying a function of the variable t. So it's just kind of giving the name of the function and describing what variable it's using in that function. So it could be lots of things. You could have f of m, and that would just mean that your function would have the variable m in it. Okay? But let me continue. There's a few more things I want to talk about. What if I have f of a number? What if I have f of 5? Well, what that means is it means the function evaluated at 5. 5 is replacing what was x, right? It's telling us, it's not telling us f times 5. It's not trying to tell us any kind of math like that. What it's saying is it wants you to use your function, but evaluate that function at 5. So if your function was 3x plus 4, well, this is telling you that the x is 5, and it wants you to plug in the 5 for x. So it's the function evaluated at 5. So f of 5 is equal to 3 times 5 plus 4, which would be 15 plus 4, which makes 19. So f of 5 equals 19. Again, this is the same thing as saying y equals 19. Okay, but f of 5 is being more specific than y. F of 5 is saying that, hey, we had a function, and we plugged in 5 into the function, and what we got out was the answer 19. Now, there's even more to it than that. F, as I mentioned, is the name of the function. So we could have a function called g of x. This is still a function of x, but the reason why you would do this is if you had two functions that were different from each other that you needed to kind of differentiate, be able to tell the difference between. So g of x would be an entirely different function. It could be, for example, 2x minus 8. Okay, just to give you an example. It's still a function of x. X is still the variable in that function, but instead of calling it f, I'm calling it g. It still means the same thing as y equals and all that, but the reason you would do this is if you had two functions and you had to tell the difference between it. Remember, this is giving it a name. This is the f of x function, so it has the name f, and this is the g of x function, so it has the name g. It's essentially just giving that function a name so that we can talk about them and describe them and be able to tell the difference between them. So for example, you might have on a test f of x equals 3x plus 4, and you might have g of x equals 2x minus 8. And then the question might ask, find f of 2. What that would mean is that it would want you to use the f function and plug in 2. And if you had a second question that said find g of 3, then it would say it's telling you to use the g function and plug in 3. So that's why we would have different names so that we know exactly which equation to plug into. When it says f of 2, I know that I would plug it into the f function. When it says g of 3, I know I'm plugging it into the g function. Okay, if I called them both f of x, right, then you wouldn't know which one to plug it into. It would be all sorts of confusing. So that's why we give them different names, so that if you are called upon to plug in a certain number, you know which one to plug it into. Okay? So now let's go back to this. So Amanda babysits and charges $5 per hour. So if she works 1 hour, she makes $5. She works 2 hours, she makes $10. 3 hours, 15, and 4 hours is 20. So the amount that's earned, the amount of money that she earns, is $5 times the number of hours she works. So if she worked 8 hours, it'd be 5 times 8 because it's $5 per hour. 5 times 8, and that would be the amount of money she would earn, which would be 40 in that case, right? So the independent variable is the number of hours she works, and the dependent variable is the amount earned, because the amount of money she's going to earn depends on the number of hours she works. So for us to write an equation, we'll let the dependent variable, which is our amount earned, which is y, equal 5 times our independent variable, which is x, which is the number of hours she works. So the equation for our situation is y equals 5 times x. That says the amount that she earns is 5 times the number of hours she works. Right? And for example, the amount she earns if she worked 1 hour would be $5. The amount she earns after working 2 hours would be $10. Right? So that's where that table comes into play. You can see that the x values and the y values you get out. But to put it in function notation, right, we don't use y equals. We'll write f of x equals. So it's the same thing as y equals, but it's saying a function of x is 5 times x. All right. Now, B, the admission fee at a carnival is $9. Each ride costs $1.75. How much does it cost to go on the carnival? To go to the carnival and then go on 12 rides. So first, we're going to fill in these blanks. So we have 2 variables. Well, first off, let me backtrack. Keep in mind, if there's values we already know, they're not variables. Variables are things we do not know. So for example, I know the admission fee is $9. That's not a variable because I know what it is. Each ride costs $1.75. That is not a variable because I know what that is. What I don't know is how much money I will spend at the end of the night. How much money will I spend in total at the carnival? And how many rides will I go on at this carnival? Those are the 2 variables. The amount of money spent, or you can just say cost if you want to. Okay, that's one of the variables. And the other is the number of rides that we go on. So of those 2 variables, which ones depend on the other? Does the amount of money I spend depend on the number of rides I go on? Or does the number of rides I go on depend on the amount of money I spend at the end of the night? And it should be obvious, right? The cost at the end of the night will depend upon how many rides we go on. The number of rides we go on will affect the final cost. So because that affects something, the number of rides is independent. And because the cost is affected by the number of rides we go on, that cost is dependent upon the number of rides we go on. Depends on the number of rides. Dependent is cost because that's depending upon the number of rides we go on, and independent is number of rides because the number of rides we do will affect the cost at the end of the night. So let R represent the number of rides that we go on. A function for this, you could think of it as y equals, but we're going to write f of r, a function of r. What equation can I use that would tell me the total cost of the carnival at the end of the night? Well, I know that I have to pay a $9 fee to get in, and then every ride is $1.75. So a good equation for this would be $1.75 r plus 9. This is saying that for every ride I go on, it costs $1.75. So it's $1.75 times r, because it's $1.75 per ride. And then plus 9, because the 9 is just the general admission fee. So the r goes with the 175 instead of the 9, because 175 is how much the rides cost, and the 9 is not how much the rides cost. The 9 was just the admission fee. So r stands for rides, so it makes sense that r would be with the cost of the rides. So now, if I want to find out how much it'll cost to go on 12 rides, I'm evaluating f of 12. So what this means is I'm supposed to plug 12 into my function and see what the cost is. My function would be 1.75 times 12 plus 9. So I'm plugging in the number 12, and f of 12 ultimately equals, if I evaluate this, $30. $1.75 times 12 plus 9 is $30. So it'll cost $30 to go to the carnival and go on 12 rides. And last but not least, number 4, Kate earns $7.50 per hour. How much money will she earn after working 8 hours? Now, this is really a part A and a part B. Part A is what we're going to write our function based off of, and then part B is us plugging into that function. So we're not actually going to focus our attention on this at all until we get to that part B, until we've already written our function. But first, I want to identify the independent and dependent variables based solely on this. And then I'm going to write a function and function notation for this. So independent variable and dependent variable. Now let's think about this problem. Kate earns $7.50 per hour. So there's two things that we know how much she makes in an hour, but there are two things we don't know. One, the variables are how much money she's going to make overall. And the second one is the number of hours she works. Because the number of hours she works could change. And as that changes, the amount of money she makes at the end of the night would change as well. So what depends on the other? Does the amount of money she make depend on the number of hours that she works? Or does the number of hours she works depend on the amount of money she makes? Again, the answer should be obvious. Which one affects the other? The number of hours she works will affect the amount she makes at the end of the night, not the other way around. So independent is the number of hours worked, and dependent will be the amount of money earned. So now let's write a function for this. I'm going to call this function f of h. So I'm going to call the function f, and I'm going to use the variable h because h is my independent variable, is my x value, if you will. Remember, independent variable is x values. But instead of using x, I'm going to call it h to represent hours. Now, Kate earns $7.50 per hour. So this is essentially y equals, or f of h equals, 7.50 times h. Because what I would do is I would take 750 times the number of hours that I work, right? If I worked 1 hour, I would have 750 times 1 because I worked 750 for 1 hour. If I worked 2 hours, I would have 750 times 2 because I worked 750 each hour. So 750 for 2 hours, I'd multiply them together and I would have $15, right? So that's why my function is 750 times h, because it's 750 per hour. So now let's go to part 2. Part 2 is how much money will she earn after working 8 hours? So now we're going to use this function. We're going to evaluate for 8 hours. So since my function is f of h, and I'm looking to find out when h is 8, right? 8 hours of work, I'm going to find the function f of 8. F of 8 tells me that I'm plugging in 8 into my function. So I'm plugging in the 8 for my h. And I evaluate. This comes out to equal $60. So f of 8 is $60, meaning that the function at 8 hours is $60. I'm going to end the video there. We'll talk about domain and range later on. I'll see you guys in a bit. Bye. Oh, by the way, the homework was on the top of this, if you're wondering. Hopefully I didn't miss it. Homework is page 131. There was 1 through 5. Honors had 1 through 5, and 13 through 15. But regular just had 1 through 5. All right, I'll see you guys in class. Bye.